Obviously, when we are told of these product rules or quotient rule and whatever rule, chain rule, you need to look to the formula sheet. So the formula sheet tells us, as you can see it, in other words, this is u of x times v of x. Then I'll just use my pencil to write my u and my v. That's what we have. Then what does it say next? Exactly that. The derivative of u is 1. Then you multiply by v. 1 times anything is that thing. Then the derivative of v is 1. 1 times anything is that thing. So, I thought it's a quotient rule. I really left a space for dividing by something. This is a product rule, so you don't have to divide. Then you can just open the brackets if you want. Otherwise, even if you leave it like that, you are still correct. You will get your full marks. So you can just open your brackets and simplify it a little bit. So you have your which equals 2x minus 2. If you want, you can do it different, because if you want, you can just multiply this out. If the question didn't specifically say use product rule, you could use a different way or different approach. So that approach will look like this. You'll just multiply out those brackets. You'll end up getting x, okay, your y, therefore, let me put a line here. Your y therefore will equal to x. Okay, if I say x times x, that is x squared. X times negative 3, it will be negative 3x. Then x times 1 will be positive 1. Negative 3x plus x, it will give us negative 2x. Then finally 1 times negative 3, it will be just negative 3. Then now we'll want our dy over dx. This will come to the front. Here, this is to the power 1. 1 times 2 is 2. For that one, it just went straight to the simplified version. This one was fun even there, because we want to know if you can use the product rule. We do not want you to really simplify. So that is fine. You can just put it like that and then you are correct. But just don't make it float as I did. I thought I was going to divide, since I already have a quotient rule in my mind. The reason I'm doing this, I want you to know that no matter what rule you are using of differentiation, the answer must be the same. So that is why these rules, they always go together. So you cannot use a different rule and think that you'll get a different answer because you used a different rule. No, all of them will give us the same answer. Okay, so that was the first example. Then let's move to the next one. This is what we have. So again, you can just say this is your u and that is your v, and then you start your process. Let us derive. There's nothing you can do. You can just go straight to dy over dx for this particular example. So let's derive u. Remember, for this one you can start with anyone, but I'll start with u. So my u will give me 2x ln x. Then I can go to v plus x squared times, then I derive v is 1 over x. Then I can leave it like this or I can add it up, doesn't matter, it depends on me. E raised by x times cos x. Then obviously they are multiplying each other, that means we have u and v. Then let's apply what we need to apply. Dy over dx is equal to What is the derivative of this? It stays the same. What is the derivative of that? It becomes a negative, so that means we'll have a negative e raised by x of sine x. So this will be the answer for this one. You can move further, number 4. Maybe we can even say ln x squared over x squared, so that you can fight with the confusion. Now obviously, if you are told to use the product rule, you have to rewrite this thing. You can't just do it without rewriting. So let's first rewrite it. When we rewrite it, we know that for us to apply product rule, we must not have a denominator. That means our x, especially x, should not be our denominator. We can have a denominator if it's not x. So x must not be the denominator. So in other words, we'll have x to the power minus 2. Then as we have logs, what is the principle of logs? If we have an exponent, it will bring it to the front. So that is the principle of the logs, one of the laws of logs. So that's what we'll end up with. Obviously, this will be our u and that will be our v. Okay, as I'm looking here, I can see if I derive u, I'll get a negative sign. So that means I will start by deriving v, because I want the first term to be positive. It's just me. You don't have to do that. You won't be marked wrong if you didn't do what I'm doing. So let me start by deriving my v. So I'll end up having 2x to the power negative 2 divided by x, because remember this is 1 over x times this thing, which will give me this. Then I say minus, because when I derive this I'll get a negative. So minus 2 times 2 will be 4. Right, so I have 4. Now I have ln x. Now remember we derived this one, so that means we'll have minus 1. So it will be minus 2 minus 1, which will be minus 3. So that means it was x to the power minus 3. So when it comes beneath the line, it will be positive 3. Alright, for this particular one, let me explain it further on this side. I'll just do a small portion of it here so that you may really understand it. What did I do? I said dy over dx is equal to, now for my dy I have 2x raised to the power negative 2 times 1 over x. Now I started with v, obviously, as you can see. This was just put as it is. Then I said plus. So I had 2. Okay, let me just write 2 times negative 2. Now the negative 2 is this one. This is 2 times negative 2 of this. It's an exponent of x, negative 2, negative 1. Then we put this one as it is, ln x. The next thing to do, I just multiplied out, so I ended up with, alright, if you can see this is to the power negative, isn't it? Since it's negative, you can just bring it to the bottom, so you'll end up having 2 over x squared times this x, so it will end up being x cubed. Then positive times a negative, obviously it's a negative. Now this is to the power minus 3. So when it comes underneath the line, it will be positive 3. Okay, but let me start here. This is negative. 2 times 2 is 4. Then this will come underneath the line, -3, so we'll have 3 underneath the line. Then we're left with ln x. So this will be the answer. If you want, you can just say 2 minus 4 ln x divided by x cubed. There is another law that we can use to solve this one, so that is why I'm noting it. I want you to keep it in mind so that when we do that other law, when we come to this problem, we can use the same law and see if we will get the same answer. We have to get the same answer. Then obviously this is my u, this is my v. Therefore dy over dx will equal to, I can rewrite it before I do that. That was my y is equal to what did I do now? Okay, so let's first rewrite it. It will be x raised by 3 over 2 into x squared minus 1. Let's derive our u if you want to start with u. So we have 3 over 2 minus 1 into x squared minus 1 plus, then let's derive this one, x raised by 3 over 2, then times the derivative of this is 2x. Then you can rewrite it if you want, or you can just leave it where it is. You don't have to rewrite, only if you want to rewrite it where you rewrite, because the concept is what we are mostly focusing on at the moment. So we have 2 times -1, which will be -2. 3 minus 2, that will give us 1. 1 over 2, it's a half. So we can end up having 3 square root of x, because half is square root of x, into x squared minus 1, all of that divided by 2. Then we say plus, then this is 2x square root of x cubed. So this is what we will end up with. Again, we are using product rule. That means this is my u and this is my v. So how can I derive dy over dx? Let's look to the formula sheet. What is the derivative of this one? Will be 2 raised by x ln 2. So I derive this one times this one. Just put it as it is, x squared plus. Then I move a little further, I derive this one and leave that one. So I'll have 2x times 2 raised by x. So this will be my answer. I can leave it here if I want. It is acceptable. Ladies and gentlemen, see each other when we're doing the quotient rule. Have a great day.